The 10 most powerful buildings in the world. Dubai Brown Donkey Island barely made the list. The pyramid is only third. The first place costs $1 trillion. It's like being in a science fiction movie. Across the canyon, the Sky Bridge with a height of more than 560 meters. How was it built? The legendary and mysterious Egyptian pyramids. Accidental exposure. Is the construction method true or false? And that's on the Antarctic glacier. Mysterious buildings that can withstand temperatures as low as -60 degrees Celsius. How does it work? From ancient times to the present, humans are constantly pushing the limits of engineering, with masonry, steel, and wisdom carved on the surface of this planet. Numerous stunning construction wonders. This issue follows global sin. Let's enter the world's largest bull market together. Number 1 is hardly a product of Earth. Looking forward to your subscriptions and likes. 10th Artificial Island. The building in front of me is like a tree, island of giant brown donkey trees. Known as the 8th wonder of the world, IT is also the largest artificial island in the world, Dubai Brown Donkey Island. He's a rich man in Dubai who spends $14 billion, use 0.94 million cubic meters of sand, and 5.5 million cubic meters of rock. On the edge of the desert, planted maritime empire. The entire island covers an area of 250 square kilometers. It's the size of 1,000 football fields. 12,000 were built on the island. Private residences and 10,000 multiple apartments, and many luxury villas. It also includes high-end hotels, water park, golf course, shopping malls and highways, tunnel light rail, bridge, water supply, power supply, and other infrastructure. Hardest ever, the most luxurious construction project, if it weren't for Dubai, which is full of local tyrants. It is estimated that such magnificent construction drawings can't be done in any country. Construction started in 2001, struggling to survive during the global financial crisis, and then come back to life many years later. It's partly operational now. Another part is still under construction. The construction history of Dubai's Brown Donkey Island. It's a microcosm of the fluctuations in the world economy. IT is also the greatest challenge in the history of human architecture. Don't look at the grandeur of the island. It's like a rich man's paradise. Internship from initial planning to final completion. The whole project was literally impossible. Before 2001, the rich in Dubai, who have money to spend, they were no longer content to operate on land. They are determined to extend their luxurious life to the sea. So Brown Donkey Island came into being. His appearance is very local. Unique in the world's architectural blueprints, AS planned. The island will penetrate 5.5 kilometers into the Arabian Sea. IT extends for 12 square kilometers. It's connected to the mainland by a 300-meter bridge. When completed, tens of thousands of mansions will be built on the island. Hotels and tourist facilities. IT is the largest and most expensive man-made island in the world. Transform into Dubai's new business card. To preserve the island and its natural environment. Maximum integration. The designers threw away all the original building materials and no need for reinforced concrete. Finally, after a heated discussion, they decided to choose the local characteristic sand as reclamation materials, taking into account the local wave strength and high winds and torrential rain. Eventually, they built it outside the city at a height of 3 meters. A wave protection low with a length of 11.5 meters, 0.9/11 in the middle. Tourism in Dubai has come to a standstill. IT took a year to recover. In order to meet the construction schedule, they came here specially. Dozens of offshore vehicles. To reclaim and build islands. Giant Shujun ship. And we start by excavating sand from the nearby seafloor. Tilt to the designated position after the sand has been filled to a certain height. Refill with gravel to hold the sand in place. And that's time-consuming and labor-intensive. But that was just the beginning. In order to maintain the foundation as stable as possible. 16 seats in the UE. The quarry began blasting day and night. Workers will 5.50 million square meters of stone lay on top of the sand. They're like armor, secure the sand and gravel below. How delicate is this process? Even where to put each stone, it's been carefully calculated beforehand. They are carefully arranged by weight and size. Make sure every stone has it. enough support, and the gap must be up to standard, and it's done. There will also be a professional diving team launching a survey and inspection that if there is any problem, you have to redo it. This is enough to prove that Dubai's local construction of Brown Al Island's determination. By 2003, the island has been completed February 3rd. In order to prevent the seawater on the island from not flowing, the local tyrants of Dubai have launched superpowers again, make 2 openings on the periphery, even send professional personnel to check regularly every day. By August 2008, the construction of the Fongwa Causeway and Islands has been completed. The next step is to fill in the foundation. The team first found the steamroller, performed the first compaction, then one huge iron rod after another, fill in the ground. Shake of iron bar, movement compacts the surrounding sand, until around the probe. It only stops when it becomes firm. And finally, it took about 9 months. Made over 2 million holes. May 2004. Brown Donkey Island finally begins to hand over work. Since then, the largest artificial island in the world, it really entered the public eye. Although there was a financial crisis in the middle and conflicts with team designs, etc., but now, whole Brown. Most of the ground on Al Island has been put into use. The countless luxury hotels on the island, a wide variety of amusement facilities, echoes the surrounding beaches, has become a lot of people the best choice for traveling to Dubai. The construction of Palm Aluminum Island was a feat of ergonomics. It also represents the highest level of artificial island. Build one from the sea. Huge and bustling island. Absolute ridge across the sea. How is it built on the ocean floor? It's not what we think it is. Filling materials directly on the ocean floor. Instead, a clearing is cut directly at the bottom of the sea. The idea is that separates this area from the surrounding seawater, in order to prevent each steel sheet pile. There are still small gaps in between. Allow seawater to seep in. Engineers use matryoshka dolls inside the outer surrounding rock in the construction of the second floor of the steel plate enclosure. After the mezzanine, with half a pin block between the 2 layers, and fill it with enough concrete. After the concrete has completely solidified. 2 feasts, the interior becomes an airtight fence. Then drain the seawater inside. A dry clearing was carved out, but then a new challenge arose. When the seawater inside is drained, pressure from the outside of the sea will come in. The entire fence came crashing down. The clever workers came up with a solution. Good way. They got there before the water ran dry. It's filled with a tough steel skeleton. Lay another layer of 2 meters at the bottom of way-in. High concrete baseplate. This material hardens and is smoother than ceramic tile. Completely block the possibility of seawater upwelling. Go here. The whole project is less than halfway through. Then comes the main event. Workers will be inside. Put up a dense mesh of steel bars. The whole process requires careful calculation. Then seal the template, pouring with concrete. After the concrete has dried and solidified, a brand new underwater pier was built. This matter. The workers will tear down all the feasts. Then you can do it on the bridge pier. The bridge was built. Actually, the banqueting method is only suitable for the construction of bridge piers in shallower waters. Once the water depth exceeds 12 meters, the steel pipe method. First, lay a thick steel pipe into the bottom of the water, and then hollow out the sediment inside. The steel frame was then placed and the concrete was poured. You will get a solid foundation. Make a few more copies and wrap the upper end. It forms a huge underwater pier. This method is suitable for higher precision engineering. And whether it is the violation of the law or the steel pipe law, are the most advanced methods of building bridge piers today. They together represent the top, sharp undersea construction level. 8th place, undersea tunnel. Finished talking about the submarine pier. Let's talk about it next. Another construction marvel under the sea. Tunnel. You must be curious. Why are undersea tunnels being built in the sea? There's no water coming in. How are these tunnels firmly handled in the sea? What about in the water? Currently all. The world's largest undersea tunnels have been built. There are more than 20 in total. One of the more famous ones is the Channel Tunnel. China's Hong Kong Jiamacao Bridge undersea tunnel. They are all human. After adding a large number of templates above, pouring concrete, you can make the whole foundation come out of the cocoon and travel. Due to the daytime temperatures in Dubai reaching over 40 degrees Celsius, workers can't work under the heat at all. So most of the entire Burj Dubai was built, all at night. This also requires the workers showed a higher intensity of spirit and more detailed technology. It's the ultimate challenge to the limits of human construction. You have no idea. To further stabilize the foundation. What brilliant ideas did designers come up with? Due to the fact that Dubai is only a few kilometers away from the Persian Gulf, seawater can seep at any time. Penetration corrodes the steel bars in the ground. To solve this problem, engineers used cathodic protection. The steel bars in the foundation make the cathode, and then we've added the net as an anode. After turning on direct current, electrons accumulate on the cathode. To prevent corrosion of steel bars. The next step is the construction of the main body of the Burj Khalifa. Looking down from above, the entire Burj Khalifa is shaped like a desert flower. It's not just about looking good, but it allows for more comprehensive lighting. Make sure every room is bright enough. The place in the middle that cannot be reached by sunlight. Just right for building the core barrel. Install an elevator inside. To make the core barrel more stable. The architects also designed a foreshadowing structure. This foreshadowing structure can stabilize the core of the entire building. It can also be used as a corridor for people to use. Finally, under such ingenuity one after another, the Burj Khalifa, which stands more than 800 meters tall, just built, becoming another masterpiece in the history of Dubai architecture. How did it go? After reading, are you too amazing? Third place, pyramid. This is the most mysterious place on Earth. Known as one of the 7 wonders of the world, it's the famous Egyptian pyramid. What we see before our eyes. It is the largest pyramid of Khufu in all of Egypt. It's made up of 2.30 million stones, height up to 146 meters. Each stone weighs tens of tons. From the outside, it's sort of a triangular structure. So unremarkable. However, how to fit so many stones perfectly? Keep the pyramids standing for thousands of years. Definitely 99% of the builders in the world, unsolvable problems. Especially since 4,600 years ago, for the Bronze Age Egyptians. More like an impossible task. In 2013, scientists discovered a discovery at the edge of the Red Sea. Mysterious blueprints left behind by pyramid builders, as shown above. The ancient Greeks developed a unique technique. They've made the world's largest lens. Under direct sunlight, temperatures can reach 1,000 degrees, can melt any tough rock. Egypt has millions of cubic meters of limestone. Just mix them with the white dirt of high territory. Mix and pour into a pre-made mold. After cooling, minerals undergo chemical reactions. Will form. A rock as tough as the outside of a pyramid. After the Egyptians, from the structural drawings of 230,000 triangles, I chose the most perfect one. Precision construction. It finally shows what we see. How many years? Countless builders. I want to restore the construction process of the pyramid. Will find this amazing building. There are so many more puzzling details. This adds to the mystery of the pyramid. Let him be an irreplaceable presence in the history of world architecture. We believe in countless years to come he will still become the most brilliant in the history of human construction. Magnificent chapter. Second place, Polar Research Station. This is probably the most freeze-resistant house in the world. It survives -60 degrees. It allows you to move around freely. How on earth did he do it? This is the Antarctic Research Station on the Antarctic iceberg, Harry 6. It's on the Brent Ice Shelf in Antarctica. Due to scientific research activities he has to settle here. This also means that build it requires more time and more advanced technology. If you look closely, you will find that there are short legs standing upright under the Scientific Research Station. They're hydraulically bracketed legs. The reason why it is designed like this, it's because 150 meters behind the Brent Ice Shelf, the temperature around can reach as low as -0.60 degrees centigrade. The wind speed reached 160 kilometers per hour. Such a tough environment. Ordinary buildings simply cannot settle here. So architects, this row was designed. Houses with blue as the main body. The special materials around it, capable of withstanding low temperatures and strong winds. Hydraulic legs on the bottom to go with a sled. It's mobile. You can also raise and lower the height of the research station at any time to cope with the changing local environment. Since it was put into use, Harry 6 came up with great results. Effectively ensure the work process of scientific researchers in Antarctica. There are countless research stations like this that it's the ingenuity of architects. It is another perfect collision of construction and knowledge. The first desert city. This is the planned cost $0.1 trillion Saudi future city project. He crosses deserts, mountains, and valleys, stretching 170 kilometers. That it's not like most cities. Saudi future city. Innovative construction into ribbon patterns. The whole city is 500 meters high, 200 meters wide, stretching from the Red Sea to the interior. This particular shape makes him very futuristic. What's even more unimaginable is his entire city periphery, all wrapped in huge glass curtain walls. From a distance, it seems invisible in the desert, and the nice thing about that is that it refracts sunlight. Maintain a constant temperature throughout the building. It can accommodate 9 million people. The entire city is fully powered by renewable wind and hydrogen. The energy it provides, all household waste produced, all can be recycled. According to the initial plan, that it's a completely car-free city. Delivery and delivery throughout the city are provided by drone delivery. Subway speed increased to 500 kilometers per hour. Here it is. You only need a few minutes to get your takeout. You can reach any city in 20 minutes. The sense of technology and futurism is vividly reflected. The ground is all green areas. The middle floor is where people live. This is just science fiction. Scenes that only appear in novels. At first, people also thought that this would look like ethereal design. There will be no surprises. And then, the Chinese construction company has actually reached a cooperation with Saudi Arabia. About to chew this hard bone. The project is now officially under construction. Will the future be able to demonstrate the sci-fi feel within the project blueprint? That we'll see the 10 most powerful buildings in the world. Which one are you most amazed by? Leave a message to tell me. Remember to subscribe, to like, share. Global Best Daily Update. See you tomorrow. Items that cannot be ignored in the history of architecture. Compared to tunnels on the ground, the construction of the submarine tunnel is definitely more difficult. This also requires engineers and construction teams have come up with more advanced technology. Now all over the world, there are two main ways to build an undersea tunnel: immersed tube method and shield method. The immersion method is to a prefabricated tunnel tube sinks to the bottom of the sea and then spliced together at the bottom of the sea. Make a complete tunnel. China's Hong Kong-Macau Bridge undersea tunnel. It was built by the immersed tube method, but this method is only suitable for areas with shallow seas. The deeper waters require the shield method. This method requires the use of large shield machines. The front of the shield machine has a large cutting device. You can rotate and cut the tunnel while moving forward. The back end has a hard shell to support the dead circle. There is also a precision splicing device in the middle. Can splice jade concrete into shape, forming a hard tunnel wall. From the appearance, the whole shield machine is like a giant python advancing. Cut a tunnel under the sea. This is by far the most expensive method available. Just a large shield machine costs a lot of money. This is real money. World-class engineering piled up. The 7th offshore drilling platform. You think offshore drilling platform. It was built from the bottom of the sea. It's not actually. These drilling rigs will advance on land, packed. Then it is towed to a fixed location for construction. He will anchor to the bottom of the SEA.AT this time. Due to the shaking of the sea surface, the whole rig will sway from side to side. It's completely impossible to carry out mining operations in this situation. To solve this problem, water filling will be carried out at the bottom of the platform. This will make the center of gravity of the platform dive below the surface. The whole platform becomes much more stable. The structures on the rig are also very interesting. And on the edge there's the crane. There is also a living area for the staff next to it. There are also tarmac workers and crew around. Back down there are lifeboats. You can escape at any time in the event of an accident. The most important thing is the torch tower next to it. He will burn the combustible gas and the oil in time. Ensure safety. Avoid accidents. That's the structure. Let's talk about it again. How did he get there? Oil was extracted at a few hundred meters. When performing homework, the tower crane and the platform will place the drill bit into the casing. Put it on the bottom of the sea together. After reaching the bottom of the sea, the drill will start quickly. Go straight to the deepest area underground at a certain depth. The casing will stop diving. The drill will then continue to reach the predetermined depth. Then retrieve the drill. Place a smaller casing than the original. Inject cement into the channel, and using high pressure, press this cement to the periphery of the casing. After solidification, he forms a tough pipe that do it again and again, until I saw oil. Our cement casing is also formed. And then comes the oil work. This is easier said than done, it's not easy to do. This highlights the value of oil. No wonder oil is so expensive. The sixth place. The subway passes through the building. If you don't see it with your own eyes, you have no idea. The subway can not only pass through underground rock formations, you can also travel through high-rises and modern cities. Let's do a delicate double manufacturing. China's Chongqing Ion occupies the subway building. It has become a local attraction. It wasn't just the locals who were amazed. Even world-class engineers came here to clock in, appreciate humanity together. Great works in the history of subway construction. Take this subway. Not only can you have a panoramic view of the city scenery, you can also feel the tension and excitement of the subway going through the building. And this is an amazing project that it's also quite difficult to build. Affected by urban terrain and traffic, the influence of density and other factors, the subway may give up its way through the ground. Choose to go through the building. Minimize losses. As early as 2000 years, when the city has decided to convert commercial buildings and subway stations, build at the same time. That is to say, from the time the nearby building was first built. It's already been set aside in the design. The space where the subway passes through the building. In order to ensure the smooth operation of the subway, and it doesn't interfere with the surrounding residents, subway, and residential buildings. A completely self-contained construction system is employed at the same time the monorail rushes up. Rubber tires and air springs support the body. It also reduces vibration and noise during driving. Full of details. If you have the opportunity, you may wish to experience it. Feel the beautiful sparks of the collision between the subway and the city. Fifth place. This is the world's first high-altitude bridge. It is located in Guizhou, China. Beipan River on the border with Yunnan. The bridge spans Yunnan and Guizhou provinces. Total length 1,311.4 meters. The vertical height of the bridge deck is up to 565.4 meters. That's 200 stories tall. If you stand on a wall and look down, your legs will be shaking. People with acrophobia may pass out on the spot. Driving on a high bridge like this, like walking on the clouds, absolutely the most thrilling experience. The official data shows that the entire bridge weighs 30,000 tons, using tens of thousands of steel components and 8.55 million sets. High-strength bolt. What's even more amazing is that there are no piers in between. Look around. He just completely vacated a superstar bridge built in order to make the entire bridge stand firmly in the sky. 112 pairs used by the construction party. 24 up to tens of thousands of stay cables lifted the entire bridge like a dragon rising into the air. In the valley, his legend is written. Such a magnificent and high-precision building that it's not an exaggeration to be in the top 5 in the world. The fourth tower. Dubai is not just home to the stunning brown donkey island, more memorable Burj Dubai. The height of the entire tower has reached a staggering 828 meters. Materials alone. I used 330,000 meters of concrete and 62,000 tons of steel. However, expensive building materials. Not the best part about Burj Khalifa. How to be in the desert. An 800-meter high Burj Khalifa will be firmly established, and that was the real shock of the project. Dubai is located in the desert. Engineers go 140 meters underground that can't find hard ground. This means that if you build the foundation directly on the ground, due to the loosening of the sand, the whole tall building will crumble. How to solve it? What about this world-class problem? The clever engineer came up with the idea. Lay under the foundation. Countless friction piles up to more than 30 meters high. They go deep into the desert. The deeper you go, the more friction. Eventually, all the friction piles and sand mixed perfectly, formed an unbreakable force. The whole process took almost 2 years. It took a lot of human and material resources to complete. Here we go. Workers will build the valve body on top of the friction piles. They used a lot of strength steel. We weld them.